The only thing hotter than speculating on Trump 2.0 policy might be speculating on what the next big tech thing will be. And lately it's been quantum. Joining us, a stock that's reaped the benefits, Spectral Capital, ticker FCCN, up 100% in the last 3 months. The chairman, Sean Brehm, is with us. Sean, thanks a lot for being here on the Schwab Network.
Thanks for having me. Nice to be here. Thanks.
It's been an exciting couple months. You guys describe your business as deep quantum tech platform. Tell me what that is. What's deep quantum?
Yeah, so essentially once you get into anything with deep quantum, you're looking at, getting down to the 2 nanometer level. And what makes us, I think, unique about deep tech is we're leveraging an existing semiconductor market. So I'm one of those guys out there that's going to be bullish on a semiconductor ETF, because right now the current groupthink is to use a bunch of scientists to make a room to make this environment really cold, to protect these little fragile qubits. Whereas you can actually leverage the power of engineering semiconductors with quantum capability. That's called a quantum hybrid approach. And now you can get these semiconductors that are already working down to 2 nanometers to move and compute data at near speed of lights. So that's kind of the deep side of it, is going deep into the tech and enabling existing technologies to get quantum effects.
Okay, so are they like quantum effects, or are they quantum effects? Is that a binary thing, or is there like an in-between?
Well, it's really kind of an in-between, because what you can do is right now the whole process is about getting these. Most people may not understand how quantum works, but you've got these things called qubits. And what you want to do is they have a very weak signal. So what you want to do is to protect that signal. And so when you want to start moving them through time and space, you want to create them really cold, like absolute zero, so they don't bump into anything, and because they're not strong enough to handle it. What you can do is instead is you stick those qubits, 1,000 qubits inside a plasmon. You use a very simple process of bonding with the electrons inside things like gold or titanium nitride in a traditional semiconductor. And now all of a sudden you're able to transport those qubits without worrying about spending a ton of money to make it really, really cold. And you get the added benefit of a 40-year industry with a $2 trillion total addressable market that's, I think, is going to go to the moon even further once it starts getting deployed.
So when you say transport the qubits, is that a way of saying activate? So they're moving, they're activating, they're contributing to the processing power?
You're actually able to carry them. So think of like, if you think of the movie Bubble Boy, and it's something really that can't be to mess with the outside world because it's weak. Well, the same thing. You actually put these qubits inside a plasmon, and you can still facilitate movement without worrying about damaging the qubits inside for processing the most important part of the data.
Got it. Because the main issue right now with applications of quantum science is that it has to operate in very, very extreme conditions, or else effectively spoiling the goods.
100%. And look, we're here because I was on the side of Jensen Huang at over there at NVIDIA, because what he's been saying is, look, it's so far out because we're not engineering this. And so what he's worried about is you build these systems that are standalone. They won't talk to this massive global marketplace called classical computing. And he's saying, you know what? We really need to engineer it. And so I think that's what's really excited, why I'm really, really bullish on the semiconductor industry, is because you can take that 40 years of excellence, you can kind of put a Hemi in it, and get things to basically protect these qubits, move at near speed of light, and it's going to have huge inputs. Everybody's talking about AI, for example. Well, your average large language model is about 350 gigs to a couple terabytes. What happens when you can take that large language model and move it at near speed of light and be able to compute it in real time? So now you're going to see that AI is actually, I think, going to be subsumed into the quantum realm. So it's a pretty exciting time to be in semiconductors, and we're looking at ourselves at being pragmatic and focusing as a quantum hybrid. We love semiconductors, we love the engineering behind them, and then we also love the concept of qubits. Let's marry the two and use some real practical engineering to make it work.
Okay, interesting. So it's almost like it's like an analog to an alloy you're trying to do, basically, to some extent, right? You're combining two themes here. So that's the bridge, basically. That's what you call it.
The bridge is really bridging the quantum compute capacity with classical systems. And the good thing is when you build a bridge, you charge a toll. Right now, if you've got these systems that we're building that can't talk to your Microsoft Windows, can't talk to your DB2 database, they're incompatible. So now all of a sudden what you're able to do is you're able to take that existing analytics software, that existing database software, put a Hemi in it, and it's running much faster, much better, and you can move much larger volumes of data at the same time. So I think this is a real turning point as we start seeing people who've been quietly, on the sidelines, just worried about the engineering and practicality coming out. And we're not the only ones saying, you know what? You can engineer semiconductors with quantum capability that deliver near speed of light compute and data transfer seamlessly. And you can integrate that into existing software. And there's some real winners out there. I mean, you look at guys that have been thinking about moving application more efficiently. Look at companies like Oracle. They have a technology called Graal VM. You're going to see that technology come to the forefront because it's going to really provide a good seamless interface to these new emerging technologies.
How much does the processing power or the efficiency, what's the measure by which you assess how the quantum integration into the semiconductors ups the power? Like, because if you are, right, because it's going to make it a better operating machine, right? But you're also not letting the quantum effects happen in a environment, like a natural environment, right? So the whole point of getting the application is to allow this thing to function at a reasonable temperature in a reasonable setting. At a room temperature. So does that detract at all from the potential power you can extract from it? How much does it add on to what a semiconductor can do?
No, it's like I said, it's like taking a Volkswagen Bug and putting a Hemi in it. When you're able to take these qubits and you're able to process them through a normal semiconductor process. Now, it's not exactly the same.
We were talking about
for those who don't understand semiconductors. You can actually leverage things like titanium nitride and gold and silver, and you can leverage the electrons inside of them. And think of the qubit, or think of the plasmon kind of creating some kind of natural bond with it, or it's skating just over the top of that metal layer, and that's what it enables you to move to near speed of light. And once you're able to do that, think about, let me, real simple example. Love a company called NVIDIA. Why? Because they're able to parallel process lots and lots of data to render a CAD file or create a really cool Pixar movie, or basically, do amazing things with AI. When you're able to take literally the amount of data that's the whole size of a large language model, and you're able to accelerate it to near speed and compute it near speed, you're redefining, compute as we know it today. And it's even better when it talks to existing software applications, because it makes sense to us that you would build this kind of system independent of what's been going on for the past 40 years, and never the two shall meet. So I think it's a much more practical approach. And again, I'm going to double down. The semiconductor market's going to be the place to be.
Okay, very exciting stuff from a science standpoint, from a theory standpoint, from a product standpoint. Well, what do you guys have at Spectral right now? Because when I pull up your financials, I see a lot. I see 0000 basically on Bloomberg.
100%.
So what do you guys got?
We've been focused on the intellectual property, building the intellectual property. We've been doing it in some other entities that we've been pulling in slowly, and just getting us to the point where we're ready to, move to the next level on the market without getting into the details on that.
What's that IP?
Really
can you give us some taste to like the IP that you're buying up? It sounds like you're buying, or you're bringing teams together. What's the
bringing
tech
teams together, buying the IP? Exactly. That's exactly what we're doing. We're kind of coalescing it into a solid plan, positioning us for the next step where we need to go in the market. And then we've got some really interesting things coming up, and how we're going to go ahead and bring that all together. What's the nature of the IP? That's the bridge. Do you is that a term? Is that a concept that you guys have protected, that you own? So there's a number of them. We have a plasmonics capability, which is the whole process around the chip. We have a series of quantum algorithms using things like analytic tomography, but really good quantum algorithms. We have a distributed quantum ledger database, which actually is a new era of database that will support quantum computing. And then on top of that, we're going to market with some intellectual property around building decentralized 2.5 megawatt data centers that can operate at the edge, because we're anticipating that you can put, let's say, a data center with about 1,500 servers in it. In the next 3 to 5 years, when you add these chips into it, into your own cloud mechanism, you've got the compute power of 50,000 servers. So you're really getting into some really interesting sustainable models, putting data closest to the edge, use quantum ledger for more security, use quantum algorithms that kind of redefine what we know as search, and these new chips that are going to go ahead and redefine compute. As you're building the IP base, have you put any shovels in ground? Have you guys built anything, fabrication, property-wise, any CapEx outside of the expenses for the intellectual property? Outside, yes, we just started. I mean, we actually have these technologies working, and now what we're doing is coalescing the staff that we're pulling from the creators. If you look, there's been some acquisitions or in the process of moving that staff in and starting to, put the wheels on put the tires on the truck and let's get going.
And then to that last point, what is your next step? Because you're a publicly traded stock now. You're up 100%. You went from 2 cents in March to $10 now. If you're early in the going of this and you haven't broke ground on a physical product, are you going to need to tap the stock at all to finance that? Or what's that next step look like?
Yeah, we're in some really great conversations. My past have done a lot in the private equity side, so it's kind of a learning lesson for me. But we're going to really be able to garner some significant players that are supporting us in some really interesting ways. And I think you're just seeing that manifested officially pretty soon.
All right. Well, keep watching. Thanks a lot. Appreciate the intro, Sean.
Thanks for having me. I appreciate it.
Fun little science chat for us in the afternoon. Sean Brehm, Chairman at Spectral Capital. Thanks again, Sean, FCCN.